Hello. So today again we talk about Bayesian networks, and this time we will talk about the conditional independence. So let's start. A conditional independence is not the same thing as a conditional probability, as you may know. The conditional probability there are at least two variables, but with the conditional independence there are at least three variables, and this is very important. Let's see the following example. Okay, we have Alice, Bob, and Charles. The situation is as follows. Alice likes Bob, but considers him more as a friend, not really as a boyfriend. So here we have Alice, and Alice considers Bob as a friend. Of course, Bob loves Alice, but is not sure about her feelings about him. This is on the other side. And then there is Charles. Charles loves Alice, but is living in the other country. Another country, and Alice, on her turn, is absolutely crazy about Charles, but she is not able to see him frequently, and she sees Bob only when Charles is not around. So with this, we can construct our data set in order to explain the conditional independence. So we have figure 1 whenever Alice is in town to see Bob or Charles, and well, of course, or Bob is in town to see Alice, or Charles is in town to see Alice, and we have 0 when a person stays at home. So the first record set says that Alice was in town to see Bob and Charles was not around. Then the second, Alice was in town to meet Bob and Charles again was not around. Then Alice was in town, Bob wasn't in town, and Charles was in town. So Alice met Charles. The fourth record says that Alice was in town, Bob was in town, and Charles was in town. But remember from here that Alice is absolutely crazy about Charles, not about Bob. And so when the three are in town, so Alice will meet Charles, not Bob. And again, we have another record when Bob was not in town and Alice met Charles. And finally, again, Alice met Bob because Charles took his airplane and flew away. Okay, that was our record set, and now we can show two structures. First, the L structure. You can see that Bob is in town, and when B is equal to 1, and when Bob stays at home, B is equal to 0. And the same thing for Alice for Charles. So we can see several things here. So, for example, we can have a situation where if we ignore for this column, we can eventually have a situation where both Bob here and Charles are in town. Okay, there is one situation here, but there can be other situation. But in fact, what this L structure is explaining us, so that there may have some statistical correlation between the event Bob is in town and Charles is in town, but there is no causality with these two events. So they only want to see Alice, and this is the true reason why Bob comes often to town and Charles as well. So even if I have some correlation between B and C, the confounding factor is A, and it better explains why you see often Bob in town and why you see often Charles in town. The real reason for Bob and Charles to go in town. Okay, this situation can be explained with V structure as well. And with V structures, with the V structure, we see that, in fact, we can consider that Bob and Charles are independent, so they even do not know each other, and the only connection that exists between Bob and Charles is Alice. So, if Alice is not there, if you, for example, you can analyze data about Bob and Charles, you don't take into account Alice. So again, you will see some correlation, but the main reason for that is the presence of Alice. So Alice is making connection between two variables, and as well as here, in the case of L structure, when Alice is a confounding factor. for A and B. Oh my God. So, and to finish, what can we say? So, there are several important things to remember from this short lesson. Even if Alice see more frequently Bob, so statistically you will have the conditional probability of A conditionally on B will be higher than the probability of A conditional on C. This is statistically, but uh, just because Charles is not around. So even if Alice sees more frequently Bob, this does not mean that she prefers him. Okay, that's the first point. So the statistical correlation is not the same thing as the causality, because with the causality we want to understand what is the cause, what is the consequence. So with the with these two structures, L and V, we try to see the cause and the consequences more in detail, and this is not especially related to statistics. And with Bayesian networks, we're interested to find the causality, but sometimes it's not coming directly from data. Okay, that will be all for today. I believe you need to read this and watch this video several times in order to understand everything. And there will be more examples. Since the conditional independence is a little bit complex topic, so we will give you more examples in order to make it perfectly clear. Thanks for watching.